In this video, we are looking at the model quality of business process models, in particular BPMN models. We're looking at how to ensure the quality, why we would want to ensure the quality, and what things we need to look at in order to get a good model. In this second part, we're looking at semantic correctness and model conventions. Let's dive into semantic correctness. Semantic correctness. In one sentence, does the model express what it is supposed to express? Does the model actually say what the modeler wanted to say with it? Because a model is a communication tool between people or between computers and people. So does the model actually capture what we wanted it to say? That can be subtle. Let's look at this example. Here we have a process model of two parallel steps, namely send goods and receive payment. The model says that these are parallel. And there is nothing wrong with this model. It is a process model. Syntax is right, the behavior is right, but do the semantics, are they right? Now, if the text said the goods are sent and the payment is received, then yes, that is what this model expresses. So what we then say is this model is semantically correct. However, if we want this model to express that after payment is received, the goods are sent, then this model is not semantically correct because that's not what the model expresses. The model doesn't capture this constraint of ordering. So the model says they can be done at the same time, while the text says one must be before the other. That's a semantic correctness issue. Here we have a large process model of products going either from Amsterdam or from Hamburg. And it can be that we are in both. But the text says products are shipped from either Hamburg or Amsterdam. But that's not exactly what the model says. If we look carefully at the model, there is a way that the order does not contain any products from Amsterdam and does not contain any products from Hamburg. There's furthermore nothing wrong with this model. The syntax is right, the behavior is right, we cannot get stuck, no deadlocks, no life locks and so on. But still, that's not exactly what the text said. So the model said there can be orders that have products from neither Amsterdam or Hamburg. Well, the text says it must be either. So that is also a semantic correctness issue. Now, how can we assure the quality? And within that, why would we bother? A computer for semantic quality doesn't care. Doesn't matter. Computers don't understand what is the meaning behind it. They just see the process model. They don't care what was to be expressed with it. Doesn't matter. They also have no way to verify that. Unless you go into things like natural text processing and so on. But in principle, computer has a program code. And what does the computer know about what you wanted it to do? Computers are very stupid. They just know what you tell them. And if you tell them this process model or this program, then yeah, that's it for the computer. They cannot check it. For people, however, what if that process model has a semantic quality issue or is semantically incorrect? Then given that process models are a tool of communication, you have a miscommunication because the model doesn't tell what you actually wanted it to say. Now, how to assure semantic quality? That is difficult because you need to look very careful at the model and what it is supposed to represent to see whether they match. And to find out what the model is supposed to represent is also very difficult. And we will get to that in the second half of this course. This is not a trivial task. So how can we check that? Well, it is a good idea to have in your organization, a large organization, a so-called center of excellence. That is a center of people that know about process models and that know about the business that the organization is in. So they can engage with stakeholders to find out how the process model should actually, what it should look like. So a center of excellence is kind of a group of dedicated people to process modeling, and they can help the actual modelers in assuring that the model is correct. You can apply peer modeling. So rather than modeling by yourself and then presenting the results, you can model with two people, and that may actually save quite some time because you don't need to gather the whole people and then get back and so on and so on. Review is another option. So when the model is made, it is reviewed by people who have some domain knowledge about the process. And finally, sign off is also important, that the right stakeholders, for instance, the process owner, the manager of the process stakeholders, that they know what is going on in this process model and they sign off on it, and then it can go into further use, like a process repository or process optimization efforts. So this is not a trivial task. Don't underestimate how difficult it is to get the semantic quality of a process model in order. Next up is model conventions. So we've talked up till now about structural correctness, behavioral correctness, and semantic correctness, and you can summarize them simply in correctness. And even though there is a little bit of a gray area, a model is in principle correct or not. So a correct model expresses what you want it to, semantic correctness. It doesn't have any issues like deadlocks or dead activities, behavioral correctness. And it doesn't have any violations according to the BPMN standard, structural correctness. The next one is a bit more vague and not so black and white. Model conventions are used to ensure the pragmatic quality and the readability of process models. So this can be in terms of programming, kind of analog to coding standards. So it's not that if you violate these model conventions, it's not that it's immediately completely unreadable or immediately the world will collapse. But in the end, if you have 1,000 of such models in a process repository and you need to look through 10 or 15 of them, it is very nice if you have nice model conventions that limit and beautify the models you have and make them more readable. So we can restrict in model conventions 3 things. The syntax, that is by avoiding certain elements. So for instance, the model convention could say, I don't want an OR join. We can limit the semantics. That means that we instruct people to avoid particular meaning. It is rare, but an example is, for instance, that we are not going to use the XOR gateway to model decisions with extensive data, something like that. And we can limit notation. That it means that we enforce a particular layout style and we enforce a particular labeling of our BPMN elements. Model conventions are context specific. If you're doing a pilot and it's a rather small effort and kind of quick and dirty, you're just discussing with stakeholders and you're scribbling something on a whiteboard together, then that is much more free than if you're in a large organization where you work with 10 people on a process model, then another group verifies it, and then yet another group is going to use that model to optimize business processes. Then you want a bit more strict guidelines, just as with coding standards for program code. I already mentioned that as an example of modeling conventions, you can avoid OR gateways, and that is actually a very good idea. So other typical model conventions that we encounter are that you model from the top left to the bottom right. And this sounds like a no-brainer, but yeah, just think of Eastern languages where they might write top-down, or Arabic languages where they write from right to left. In general, it's a good idea to avoid crossing, so you don't want things laying on top of each other, or as few as possible crossing sequence flows. They just make it harder to read everything. And another very typical one is that it's a good idea to split models of more than 30 elements. If you cannot fit it on an A4 paper readably, then just split it up into submodels. Very high chance that your model will become unreadable if you have 50, 60 elements. Another set of examples of modeling conventions are the notation, but more around the labels. So it is a good idea to, in a modeling convention, describe what the labels should look like. And that's not to bully everyone and to be able to reject their models at will because they didn't know this, but this is to make models more readable. If you have a repository of 100 or even 1,000 models and you have to look through them, then it's very, very useful that all the activities and all the events and all the conditions have the same type of grammatical structure. Then it just takes less brain cycles to parse them. So one example that is often used is for the activities, we use the imperative verb plus a noun. For instance, check form, or send product, or create invoice. If you just use this structure, then it is immediately clear what is being done and what is being done on. Notice that this does not include who does it, because for that we have the resource perspective. For events, we use a noun plus a past participle. So for instance, form received, process started, invoice sent. So we use a past because an event is something that happened. So that's why we use the past. For conditions, in this example of modeling conventions, we reference data explicitly. So out of an XOR, an XOR split, we don't just say yes or no, but we say form complete and form incomplete. Now imagine that you have a process model and you're looking through it and you're kind of just browsing it, and which one is easier to understand? It's obviously the one where you mentioned the full data and the full property. If this process model is later on going to be implemented, people will thank you for this, because yes or no, what does that mean? It's not so easy to grasp. You need to look back and then maybe they meant this, maybe they meant that. No, just put the whole thing there and it's much easier to read. Just from a mile away, in particular for the notation and the top left to bottom right, look at these two models. Even though you cannot read the labels probably, you don't need to read the labels. You can see that the bottom one is much more flowy, much more aligned and nice than the top one. And the top one isn't wrong, so layout is always a bit subjective, but for these two, I think we can say that the bottom one just looks much nicer, and that's in the end much more readable, simply because it takes less brain cycles to parse it. A note, and a repetitive note, is that conventions are not universal, similar to coding standards. There are multiple versions of conventions around, but there is no one way to do this. There is you can make up your own coding standard, your own modeling conventions, and if you stick to them and they're well designed, then it will work. Somebody else might come with others, but yeah, that's just how it is. There is one thing else that you might want to consider when looking at modeling conventions. And that property is called proper completion. And it entails that no end event shall receive more than one token. This is a convention. But let's look what it looks like and play the token game. We start with a token. The end splits that token, then A starts executing, and when A finishes, the XOR join takes this token and forwards it to the end. But then the B also executes, and the XOR join doesn't synchronize anything, it just forwards the token, and then suddenly we have two tokens in our end state. Now, why is this a problem? This can be a problem if this is not the end state, but another task there, for instance, pay compensation. That is then executed twice. So it's a very good idea to avoid this situation in any cost. If we have two tokens in the same end event, then we have not always proper completion. So there is a way that we can get to the end state with two tokens in it. That means that this model violates the proper completion property. Similarly here let's again play the token game. We have a token, the XOR join doesn't do anything, just forwards the token. We execute A, and when A is done, we are before a AND split, which generates two tokens. One proceeds to the end and the other one goes back to A, which is executed. And then we are back again here in the situation. But now we're gonna have two tokens in the same end event. So again, this might be a problem. And this is hopefully even clearer than the previous one, is a real problem, because this token that goes around here kind of produces tokens to the end event and without stop. So not only do we have a live lock, but we have a token generator that fires tokens forever. So if there is a pay task after at this point, then this pay task is going to be executed an infinite number of times. And naturally, that's something we don't want. So this is, again, a convention. So the convention is make sure that your model has proper completion. But it's not required by the BPMN standard. So the models I've shown you are valid BPMN models, of course fragments. Now, how can we assure the quality of the modeling conventions, and what should be what should we care about that? For computers, they don't care. That there's no problem in reading a badly layouted model where the labels don't make sense. The computer doesn't care. Doesn't know anything. Doesn't know what to do with it anyway. However, computers can assure some of the conventions. For instance, if we say avoid OR join, we might give a warning when somebody tries to use an OR join. And also, adapted syntax checkers might warn for missing labels. So you see, I leave them out of the examples I use in these videos because they would clutter too much. But I give you on a note that if you leave all the labels out of your process model, it's going to be very hard to read. So it's a good idea to add labels everywhere. Now, computers can check that, of course, easily, especially if you use a dedicated BPMN modeling tool. Proper completion can be checked by computers with the same kind of caveats as our option to complete. This can be checked up until the informal semantics of BPMN. For people, models that do not adhere to certain reasonable modeling conventions will be less readable. We've already seen quite a few examples, but in general, models that are less readable, just like badly written code, it's not that you cannot understand what is going on, it's just that it takes much more effort, and that makes it more likely that you make mistakes in your understanding when reading a model. Models are a communication tool, hence it's not good. Similarly, if you have more effort to, in the first place, understand the model, it's also, of course, much harder to maintain a model. If you have a completely unreadable model, the chance that somebody else will reuse it is much lower. Similar to bad code. If you read code and you have no clue what is going on, will you reuse it? Yeah, probably not. You would look further. Again, here, how to assure the modeling conventions. So apart from the conventions that the computer can verify, again, a center of excellence might help in providing the knowledge for modelers around the organization to ensure that the modeling conventions are followed. They might tell you, okay, you can optimize here a bit, or please note that this and this and this. In peer modeling, that's also a very strong and successful way to reduce complexity of models, because it's simply more work and there's a little bit more thought behind it. Can we model it a bit nicer? Do we really need this zigzag edge here? Can we move this around and cross it? Two people see more than one. So peer modeling might help. Review might also help. This is, of course, a little bit shaky. Some modeling conventions are quite black and white, but some are a bit in the eye of the beholder. So a review then would be like, I think you can reduce the number of arc crossings by swapping this and layouting it like this. It is possible and it happens, but it's a tedious job for a reviewer. And finally, again, sign-off is necessary before a model goes into a repository. You do not want to end up with models that are pretty much unreadable ending up in the repository, and then that will just degrade the experience for the whole organization that has to use these models over and over again. You just want it to be nice, otherwise people go and do something else. This wraps up the model quality framework that we use. To summarize, we have looked at structural correctness, behavioral correctness, semantic correctness, and model conventions that each capture a particular aspect of process modeling. Structural correctness details with that the model adheres to the BPMN standard. Behavioral correctness indicates that there is an absence of certain unwanted properties such as deadlocks, live logs, and dead activities. Semantic correctness refers to, does the model express what it should express? And finally, the modeling conventions hopefully ensure that the model looks nice, is readable, and well maintainable.